Okay, hi, we're going to talk about standard form of a quadratic equation. Some people call it vertex form. I tend to call it the standard form simply because when you graph something, you want it in the most standard form that you would graph from. Like y equals mx plus b is, they call it the y-intercept, for the linear function. So what I have here is, for all purposes, it says f of x, so some function equals a, in parentheses x minus h, the quantity squared plus k, where h and k represent the vertex of your function. So a lot of people tend to call this the vertex form. So we're going to talk about if I have a polynomial, and it's a quadratic polynomial. Standard form, which just means the x squared goes to x, so the exponents are going from greatest to least. Okay, we're going to take this and turn it into something called the vertex form. And what we need to have here is that we have to have a quantity that is a square. So what we have here is an expression, but it's not a perfect square. So we have to create a perfect square within this expression. And the only way to do that, okay, is that we need to take a look at the quadratic term, we need to take a look at the linear term, and then what we need to do with that is make a perfect square of that value. So, first things first, what I need to look at is I need to basically look at this and say, okay, I need to complete the square from this. Now the thing that's important is that this -5, the constant value, needs to tag along with whatever I'm doing. So here we go. First things first, to put something by using completing the square, what I have to have is that this leading coefficient has to be a 1. Well, in this case, I can't really divide, because if I divide, then I'm losing the division of this 5 out here. So what I'm going to do is I'm going to use factoring instead. So in this case, I'm going to factor out of 3. So I get 3 times the quantity of x squared plus 4x. Okay, and I'm going to keep it in quantities, minus 5. Okay, so basically all I've done is factored this expression. If I wanted to get back to this, 3x squared plus 12x, okay, all I would do is multiply back through. So I haven't changed anything yet, okay? So all I did was change the look, but I didn't change any of the function values. And that's important because as a mathematician, you have to understand that all we can do is change the look, but we're not allowed to change the function value. So at this function here, now I'm going to do something called completing the square. And the thing that we need to be careful about here is that if I put something into this equation and it's in function form, okay, I need to put something in that really isn't putting anything at all. So I know that sounds a little bit strange, but I have to put a value in that's like adding or subtracting nothing at all. And the only number that is 0. So when I complete the square here, okay, and the way you complete the square is that it's half of this value here. So that is your b value. So your b value is whatever this linear term's coefficient is, divided by 2, and that gives you 2. But to make it a completed square, I write in that I must have this value squared. So I get b squared, okay, which is 2 squared, which is 4. So now I have all my values. I've got this positive 2, and I've got this 4. So here's the tricky part to writing something from standard form to vertex form, is that this part I'm going to complete the square. But when I do that, remember the important part here is that I really can't add any value in. So the only number that doesn't add any value is 0. So how do I add 0 in if I need to complete the square? Well, simple enough. You add 2 things in that make 0. So here we go. I'm going to write, so I still have this 3, I'm still multiplying it by the x squared plus 4x, okay? Normally I would add 4 in, okay? And that would make this a completed square. But I can't add 4 in, I gotta add 0 in. So I'm going to add in plus 4 and minus 4 inside those parentheses. So now what I've really done is kind of added 0. And this minus 5 still tracks along. So now what I do here, okay, is that I want to get this -4 out of this group, because if I get the -4 out of this group, then that allows me to write this as a perfect square group. So here we go. The way that you do it, okay, is you just distribute to get it out. So take the 3 and only multiply it by this -4. So that way I get, this problem is still 3 times this quantity of x squared plus 4x plus 4. And now I did 3 times this -4. And 3 times -4 is -12. That brings that out of the parentheses, I get a -5. So now what I'm going to do is do some cleanup out here, okay? And the next thing that I do here is I write this just simply as its squared group. So this is 3. So this is going to be, and that's why I keep the b, so x plus 2, the quantity squared, and this is -17. And what I now have is something called the vertex form. And the reason I know it's the vertex is because it's in this form of ax, okay? The a could have been a 1, and it didn't have to be a 3 here. But my vertex for this function, if I wanted to now go ahead and do that, since the original function said minus, this had to have been a -2. So my vertex, okay, I'm just going to use a capital V, is -2. And this was originally plus, that has to be -17. So the vertex of my quadratic function is -2, -17. The line of symmetry is actually just the x value of it. So the line, I'm going to use LS, the line of symmetry is equivalent to -2. And in this particular function, we can also look at, is this quadratic going to have a maximum value that it can ever reach before it starts to curve back around, or is it going to have a minimum value that it starts to get all the way down to the bottom and starts going back up? And the way you know that is by this 3. Is it positive or negative? Well, in this case, this is a positive, which means that my function is going to have a minimum because my quadratic function is going to be opening upwards. So if it's opening upwards, I have a minimum, and the minimum is always at the vertex, which is the most bottom point of a quadratic curve. So -7, so my minimum, -17. The minimum of this function is at the y value of -17. And that's the information I can now pull out of this, okay? As opposed to me now, I can graph this by hand, whereas this one, I would have to input, output, input, output, input, output. Whereas this way, I can just now get my points and use the quadratic curve function to now use the interpretations of how I can plot this by hand, which just makes it much easier. So I hope that helps with any type of homework that you're doing.